In this example, we are going to investigate how scatter plots differ in the strength of the association. Recall that associations can be positive or negative. We say a positive association occurs when the graph is increasing. So as the x values increase, the y values also increase. We say a scatter plot has a negative association if the relationship is decreasing. That is, as the x values increase, the y values decrease. So the strength of the association is how closely the data follow a pattern. In our class, because it's Introduction to Statistics, we are going to be looking at linear regression or linear lines of best fit. So in this example, we are imagining a line fits the data. In additional statistics classes, you may look at curves of best fit. It's very common for us to look at parabolas to fit data, or exponential curves, or the type of curve known as logistic curves. You may have heard about logistic curves recently in the news when they talk about how the coronavirus spreads. In a logistic curve, the values increase and then slow down and plateau. But in our class, we're going to focus on the simple linear relationships and associations. All right, so these three scatter plots show body measurements for 34 adults who are physically active, and then we're going to match each description to the scatter plot and explain our reasoning. So let's take a first look at the three scatter plots. Scatter plot 1 has a positive association. As the x values increase, the y values also increase. And of the three graphs, scatter plot 1 looks like it's the closest fit to the line. So I'm going to say scatter plot 1 is the strongest association of these three scatter plots. Scatter plot 2, the points look like kind of a big blob or a cloud. They look like they're just randomly distributed around the axes here. And so I don't think scatter plot 2 has any sort of association. It looks like if you fit a line through, your line wouldn't necessarily be positive or negative. It would just be a flat line with no relationship. In scatter plot 3, the association is positive, but the strength of the points fitted to a line is not as strong as in scatter plot 1. So scatter plot 3, we see a positive association, but we don't expect our strength of the fit to the line to be as reliable as scatter plot 1. We have three scenarios we're going to match. So the first scenario is where x is a forearm girth and y is a bicep girth. Remember, these measurements are from 34 adults, so these are the forearm and the bicep girth, which is a measurement around the outside of these parts of the arm. And these are from the same arm. The second scenario is where x is the calf girth. So again, measuring around the outside of that part of the calf in centimeters. And y is a bicep girth. So the distance around the top of the arm for the same person. And then in scenario 3, x is the age in years and y is the bicep girth in centimeters. All right, so I don't expect there's going to be a relationship between an adult's age and their bicep girth. If we were studying children, we would see, overall older children would have larger limbs and larger bicep girth. But once people are fully grown adults, there's not a relationship between your age and your body size. So scatter plot 2 is going to match scenario 3 here, where we don't expect there to be a relationship between age and bicep girth. So scatter plot 2, I wrote on the x-axis that x is the age and y is the bicep girth for the units. And so I put that this matches scenario 3 up here. Now we have to decide which is the stronger association, the relationship between forearm girth to bicep girth or calf girth to bicep girth. So since forearm girth and bicep girth are on the same arm, those are going to be more closely associated, I believe, than calf girth and bicep girth. I do overall expect, though, if someone has larger calves, they'll have larger biceps. So I do expect, in most cases, we probably have a positive association there. So I labeled scatter plot 1 as matching scenario 1, where x is the forearm girth and y is the bicep girth. And then scatter plot 3 is matching scenario 2, where x is the calf girth and y is the bicep girth. And then I put my notes here. We don't expect a relationship between adult age and bicep girth. So that's corresponding with the second scatter plot with the random points. We expect forearm girth and bicep girth to have the strongest relationship, so that's why we chose those variables to label scatter plot 1, the strongest linear relationship. Based on the scatter plots, we're going to label each association as a strong association, a fairly strong association, or no association, or you could call it a very weak association. So the association between forearm girth and bicep girth is a strong positive association. Looking at that graph, I wrote associate, but you could write association, because we saw the points were fairly close to a straight line there. The association between calf girth and bicep girth, that's a fairly strong positive linear association. The points are close to a line, not as close as in the first scatter plot, but the overall trend is linear and we can fit a line through the data. And then the association between age and bicep girth, we expect no association because adults come in different sizes and shapes, so we don't expect that your age influences your body shape.